So hi everyone. Hello everyone. Welcome to today's panel discussion on looking at NVMe over fabrics and what kind of role they play in an all-flash era and an all-flash data center. I'm going to be your panel moderator today, and my name is Ashish Nadkarni. I'm a group vice president with IDC. I cover worldwide infrastructure research, and storage is one of the areas my team and I cover. And today we are going to have a very good discussion, hopefully, to talk about some of the trends we're seeing in NVMe over fabrics, and what are some of the ways in which you can deliver that today, and what approach is going to win out in the process as these technologies mature. So the panel discussion today is divided into a few sections. I will introduce the panelists, and then we will get into the Q&A session. Each section is going to be around 15 to 20 minutes long, and each panelist will be given a question to answer. And at the end of all the questions, we will draw upon a conclusion for that particular section. So with that, let's get into the panelists. So with me today are four gentlemen from Huawei and from the US and from Bank of China. So the first one is Kevin Tolley. Kevin is the founder and CEO of the Tolley Group. And Kevin, did I pronounce that right?
That's right. Thanks for having me here, Ashish.
Thanks, Kevin. The next panelist is Zhang Zidong from Bank of China. He's a storage network architect in the Information Technology Operations Center at the Bank of China. Hey Zhang, how are you? The next panelist is Liu Lei from Huawei. He's a senior expert in the Data Center Solutions Department in the Enterprise Business Group. Hey Liu, how are you?
Hi, hello.
And then our last panelist is Wang Dachun. He's requested that we call him DC. He's the CTO of the Enterprise Business Group at Huawei. Welcome, DC.
Thank you for having me.
Thank you. So with that, let's just get into the agenda. So as you can see, there are 5 sections. The first section, which is what we're in right now, is just to introduce everyone, talk about the various types of topics we're going to talk about. The second section is getting into the digital economy as a catalyst. And I'm going to kick it off with a couple of slides. Then we will get into the panel discussion to talk about what the challenges are, and then we'll conclude. And then subsequently, we'll get into the SCSI to NVMe transformation. What are the different types of approaches with NVMe? And then, of course, what kind of solutions Huawei is bringing to the market, and how Huawei has won some of the accolades there in terms of in the Interop Award. And then I'll close out with the future of NVMe and NVMe over fabrics. So with that in mind, let me just jump into the second section, which is the digital economy as a catalyst for enterprise infrastructure transformation. Now, we have no doubt that the pandemic has supercharged digital transformation. And because of the pandemic, which started early last year, people have had to adjust and adapt to the different types of issues that have been thrown at them, and they have had to change their business models. They've had to change their global IT budgets, and the focus has been on digital innovation and transformation, business resiliency, and to kind of reinvent themselves so that they are prepared in what is to come to them, as well as for the future enterprise. And we think that this next normal, or the new normal, as a lot of people say, will be here to stay. And that means that they cannot go back to the old way of doing things. They have to transform themselves digitally. And so that it means that there are different types of enterprise investments. So for example, security is a big deal. So people have to invest in trust. Cloud is a big deal. People have to invest in different types of cloud operating models. Software, they have to create new software stacks from looking at different types of ecosystems. They have to invest in edge computing, which is a big deal when it comes to moving your compute to the data. And then finally, hybrid workforce. One of the biggest changes with the pandemic is a lot of employees had to work from home, and nobody is yet ready to come back to work. And that means that there is a hybrid workforce which has to be given access to all the corporate IT tools. So that changes how IT works. And so DX is changing enterprise investments. There's no doubt about it. But it is also creating a future-ready infrastructure, or a future-ready infrastructure which is reliable, cost-effective, innovative from a data perspective. It's real-time insights, it's agile, and then it's intelligent. And so we think that a digitally transformed enterprise is going to be, it's going to have all of these kind of key attributes to how they manage their infrastructure. And so with that, we want to get right into the panel discussions, and this is the first section. So I'm going to start with Kevin. And so the question to every one of you is, what are the challenges that are posed by digital transformation to data center storage? So we are here to talk about data center storage today. And given that, what are the challenges that are posed by digital transformation? So Kevin, I'd like to start with you, if you want to provide your perspective on what are those challenges, and then we'll go down the list and each of you talk.
Sure, and I think we'll probably hear the same things. The challenges are recognized. Performance, availability. Let me focus a little bit on one that might be a little bit less obvious, which is power. Right, we have an increasing volume and variety of data. That means exponential growth of storage devices, and power cost accounts for a very significant portion of data center OpEx, right? And OpEx never goes away. At the same time, in many countries, there are sustainability goals. Companies have increasing incentives to build carbon neutral data centers. So again, low power consumption is an important requirement. And the kind of the cooler, the less power that the devices use, the cooler they are, and that ripples through, of course, to lower HVAC costs. So in addition to the ones that I'm sure we'll hear about, let's not forget about power efficiency.
Great. Thank you, Kevin. Jiang, how would you answer this question?
The financial industry is taking the lead in going digital and developing towards omni-channel coverage. The ubiquitous financial services result in explosive data growth and drive data infrastructure innovation. And also, let me give you an example. As one of the most highly international commercial banks in China, the Bank of China operates in 62 countries and regions worldwide to improve our service and maintenance capabilities. Apart from the steady business-to-business services, we also have the rapid development of small and micro enterprise loans and personal mobile banking services. And we do see that data volumes start to soar, which requires high data concurrency. Like online shopping, the customers are no longer limited by store opening hours. Therefore, banks need to provide 24/7 services. As for latency and the reliability, of course, there are higher and higher requirements, and this is the biggest challenge we're facing right now. I would say that the banking sector is the one that has a very high reliability requirements. So data loss or data service disruption will lead to very high loss, as in the industry can cause an average loss of several million per hour. That's what I want to share.
Thank you. So then, Liu Lei, how would you look at it from Huawei's perspective?
Actually, look at the storage industry itself. The global shipment of all flash has exceeded that of traditional HDD since 2018. Therefore, the industry has reached a consensus that all flash data centers are important development trend for future data centers. In terms of performance, the SSD latency is as low as 20 microseconds, which is 1% of that of a traditional HDD. As for reliability, the 5-year SSD return and repair rate is only 0.8%, which is 1/20 that of HDD. In terms of energy saving, an SSD consumes only 1/3 of the power consumed by an HDD. So that's really a lot, right? All-flash data centers help improve the end-to-end customer IT experience from CapEx to equipment, from room footprint, power, and maintenance, to greatly reduce the overall total cost of ownership. All-flash data centers have already adopted in industries like finance, government, healthcare, telecom, and manufacturing. So, Ashish.
Thank you. That was very insightful. And then DC, how about you? Or how would you look at it from a CTO perspective?
Yes, when we talk about the digital transformation of the financial service industry, normally we will use the bimodal IT architecture to discuss. So for the mission critical application, that's normally work for the traditional, based on the traditional IT infrastructure. For this part, we will focus on performance, for example, like the IOPS and also on the throughput and also on the latency. And on the other side, if we emphasize the transformation on the agile business mode, then the data scalability will be emphasized. So that's two directions. So for the data center storage, we need to meet all these two kind of requirements for data center.
Right.
Okay.
Thank you. So I guess the conclusion that we are arriving at is all flash data centers are becoming a reality in the digital era. You know, I'm going to call on one of you to kind of conclude this section. So, you know, let me go with you, DC. Do you believe that all flash centers today are going to become a reality in the digital era?
Yes, sure. For when we consider the performance of a storage system, normally we will talk about the IOPS, IO per second, and throughput. But actually, latency may be the more important factor when considering critical application, especially for the online transaction. In a traditional data center, most of the end-to-end latency on the storage is the internal storage, internal processing. The network only accounts for a small amount of the data, amount of the time. However, in the all-flash era, storage latency can be decreased from the 2 milliseconds to the 20 microsecond level with the solid-state disk, improving performance about 100 times. With SCM, the storage latency can be even shorter. As a result, the storage network becomes a new performance bottleneck. So faster storage may require faster network to connect it. So now, actually, there are 3 methods for us to connect the solid-state storage, especially based on NVMe. So for later, we will talk, maybe discuss more about that. That's the NVMe over Fabric channel, over RoCE and TCP. Yes.
Yeah.
Let's discuss the character later.
Yeah, let's talk about that later. Thank you. So I guess the key thing here is performance and business resiliency, and that's what all flash data centers bring you. And so let's get on to the next section, because we do have some more details we can talk about. So there was a good segue into the next conversation around all flash and how SCSI transformation to NVMe and gradually upgrades to end-to-end NVMe. And so DC kind of led us into the conversation around what is happening and why is it important. So the first thing I wanted to sort of start talking about is the installed base of storage systems. Now, keep in mind that installed base is inclusive of new data as well as existing data. And we know that existing data is not going away anywhere. You are getting new data. So what you're looking at here is massive data growth, but also in the installed base of storage systems. And that is why you need high performance, you need resilient storage systems in the data center, not just in traditional IT, but also dedicated cloud and even in public cloud. And what this chart shows here is that regardless of where you store your data, you need resilient storage systems that can handle that installed base. And so what we are looking at is all-flash storage or all-flash drives to begin with. They're not only performant, but they also drive green and reliable data centers. So they consume, as Kevin pointed out, a lot less than hard drives, but they also last longer. They're efficient. And as we'll talk in a few slides here, the cost of flash drives is also coming down. And so what this means is that it is becoming a building block for green, reliable, and high performance data centers. And we need these kinds of data centers for business resiliency and everything that is to come in the digital era. And not only that, we talked about performance, we talked about resiliency, but cost effectiveness is important, because what all flash gives you is the ability to have a common platform for all your applications and workloads. And you talked about mission critical applications, DC. There are both new applications as well as existing applications that can benefit from a common storage layer in which you have you have resiliency, you have data protection, and consolidation, and that really leads to lower TCO, higher return on investment, and that's what really is driving the use of all flash. Now, given that we need to expand beyond what's in a storage array or in a server, now we need to think about end-to-end NVMe. And what this slide here is showing you is that SCSI transformation to NVMe is happening in a quiet way. But look at the numbers here. If you're looking at the number of instructions that get reduced, the number of queues, the queue depth, you're going from a traditional SCSI-based fiber channel network, and I say traditional here, but it's relatively new. But you're going from that to an NVMe over fabric mode, which uses Ethernet as the transport, and that gives you a lot faster, your access to media. Going from 2,000 microseconds to 20 microseconds, or even lower. The network is faster, the IOPS is better, the latency is reduced, and there's a lot of things that go for this. And there's some debate in the industry about what kinds of NVMe or fabric will win out. And what I'm making an attempt to show here is, if you think about Ethernet and fiber channel as the two kind of preferred approaches for NVMe over fabric, you have the RDMA approach, NVMe or RDMA. You have the whole NVMe over TCP, and then of course you have fiber channel. And so there are these three different approaches, and as we will see in the next few minutes, there is a certain Mr. Right that's emerging in this. And in fact, I think that is it's a good segue into our panel discussion. So I'm going to start with BCU, since you talked about the different types of approaches. So let me pose you this question. So in the all-flash data center era, who is Mr. Right of NVMe, given the three different approaches you just outlined?
Okay, what? Okay, my question for me?
Go ahead.
Oh,
Yep.
Okay. Okay. Actually, when we talk about the storage network to connect the storage device, till today, the widely deployed network is based on the fiber channel. So the traditional fiber channel will support to transfer the SCSI command and SCSI data. But now we transfer based on NVMe, we use NVMe to transfer data and transfer command. It's very simple, and also can provide us with much many more data queue and queue depths to improve performance. But another part we need to consider is about the latency. provided by the network itself. So based on the three methods you just mentioned to transport the NVMe, TCP can be deployed widely, but the performance of TCP is not suitable for the data center, especially for the critical application. Due to the TCP, it will have the slow start, and also due to the Windows side, the performance will be impacted, and also the high CPU consumption. So another one is the NVMe over fiber channel. Yes, fiber channel is a very good protocol, but for fiber channel, the scalability of fiber channel is very limited, and also due to the cost, due to the ecosystem, it cannot be deployed widely. For us, we think for the NVMe over Rocky is a much better choice. Since over Rocky, it can provide for example, like the zero copy memory, remote direct memory access, and also very less CPU consumption. Our direction is to deploy and develop our solution based on the NVMe over Rocky. Thank you.
That's great. Thank you. So let me go to Jiang. I guess you've deployed some of the new NoF plus solutions from Huawei. What has been your experience in that storage system, and how have you seen those benefits for your bank?
Well, compared with the traditional FC storage network, we can see that the traditional FC storage network, due to its own features, both its bandwidth and latency have become the performance bottleneck. For example, the first bottleneck of traditional FC storage is its bandwidth and scalability. We want to ensure reliable data transmission. Therefore, the traditional FC storage network has to plan for the transmission bandwidth and access capacity of a single network in advance. When there is a sharp increase of data volume, then the single network capacity will reach its bottleneck. So it has poor scalability and insufficient bandwidth. Therefore, FC cannot meet the demand of the quick increase of data volume. And there is another bottleneck. Well, the FC ecosystem is relatively weaker compared with NVMe, so it cannot visualize the fault location. So in actual O&M scenarios, using FC network will face more difficulties in terms of locating faults and also using automative solutions like automation. Therefore, we need to use a lot of third-party tools or self-developed tools. That requires a large investment in human resource. Last but not least, it is also a top priority for us, which is cost. For example, the mainstream FC is 16 gigabit per second. So the port rate is much slower and smaller than the 25 gigabit per second IP port. And also the cost of a single FC port is 4 times that of IP. Therefore, FC is unable to meet the basic requirement of future storage. NVMe is a better solution for the future. Thank you.
Great. Thank you. Liu Lei, how would you talk about the transition from fiber channel networks to lossless Ethernet, and how you see this transition happening from Huawei's point of view? You on mute? Sorry.
Oh, sorry. So let's look at the several network requirements of all-flash storage. Starting with high performance, the storage network must have high bandwidth and throughput, low latency, and high performance, while ensuring stability. Secondly, it must be able to scale elastically and support sustainable development. Finally, reliability and usability are the basic requirement of storage. The FC network has been running for decades. However, as enterprise go digital, FC has obvious limitations in terms of performance, scalability, and operation and maintenance. As the NVMe of over Fabric ecosystem matures and customers begin to adopt it, they believe that NVMe over Fabric is becoming an inevitable future trend. So Ashish?
Thank you. So I'm going to share my screen so we can conclude. So clearly you guys are making a case for, or Huawei is making a case for lossless Ethernet based NVMe or Fabric to become a hotspot in the all-flash data center era. It's clearly trending in that there are some major drawbacks of fiber channel or even TCP that prevent that high performance from really getting its full credit. And I think that's where you do want to see the adoption of lossless NVMe or Fabric, or lossless Ethernet based NVMe or Fabric. So I guess the one, before we go to the next section, Kevin, was there anything you wanted to offer by way of your perspective before we go there?
Sure, Ashish. Yeah, I concur with what the other panelists said. And if you look at where things are going, this year at the Tolley Group, we've tested fiber channel, the latest, and that's been 64 gigabit. When it comes to Ethernet, we've already tested 400 gigabit Ethernet. So I think that tells the story. When we look at as DC was saying, you look at NVMe over Rocky, and you want that Fabric, it needs to be lossless, it needs to be high speed, low latency. Again, we're already seeing a gigabit Ethernet shipping at 400 gig, so it's clearly got a very significant lead there. And I would say that's Mr. Right. Ashish?
Great, awesome, thank you. So I guess that's a good lead into our next conversation on Huawei's next-gen storage network, NoF+. It recently won the Interop Best of Show Award. Clearly there is a case to be made that Huawei storage can solve some of the limitations of fiber channel and TCP or the two other NVMe or Fabric implementations. And I think there is a case to be made that this storage does in fact shine in terms of really ultra low latency, high bandwidth, mission critical applications. So let's get into the solution itself. So Huawei released the lossless Ethernet storage solution, and it won an award. I think it's commercially deployed in some enterprises, including Bank of China, and we think that there is there's many more accolades to come, hopefully. So with that, let me start with you, DC, on why do you believe Huawei won the award, and what can you tell us more about this solution and what it can do to address some of the challenges that we talked about with other two approaches?
Yes, well, when we talk about the storage network, one very difficult feature for us to meet is for the zero data loss, zero packet loss. So we know that based on the fiber channel, there is a buffer to buffer credit mechanism to make sure there is no frame loss or packet loss in the fiber channel. Now, comparing to fiber channel, how can we achieve the zero packet loss on the Ethernet? We need to utilize the flow control algorithm to achieve that. So actually, till today, there are three phases to achieve the zero data loss. The first one is about the based on the pause mechanism, based on the IEEE 802.3 protocol. Another one is the phase two. It's based on PFC, priority-based flow control. And now it's in the third phase. Third phase is based on the DCQCN. And our solution, what we release is the iLossless network. iLossless network is the much enhancement on the DCQCN. We improve the phase of the ECM ECN, which is the explicit congestion notification. When there is congestion, the queue of the switch will be reach the higher threshold. That when we reach the threshold, the switch will send a back pressure the notification packet to the source. That is the ECN. But normally for the other vendor, the ECN threshold is static. Our solution, we utilize our artificial intelligence based on the chipset we provide, we embed in the switch. And the chipset will help us to determine a dynamic ECN threshold. So that's help us to achieve the true lossless. Okay, I think that's our competitive enhancement to the solution of the DCQCM to support the fiber channel over blocking. Thank you.
Thank you. Liu Lei, how about you from a service processing perspective? What are some of the thoughts you'd like to share?
I will share my inputs from the perspective of service processing. Huawei's NVMe over Fabric Plus offers two outstanding features. It supports more concurrent online transactions to ensure real-time processing. And it adopts end-to-end NVMe deployment to slash third-party licensing costs by 30%. Take the IT department of the Swiss government, one of our clients, as an example. This project saw the customer replace the traditional storage devices and the network with Huawei end-to-end NVMe and NVMe over Fabric Plus solution to support financial databases and applications. The legacy SAN storage system had become insufficient and took a long time to respond to database and application requests. The customer decided to adopt cutting-edge technologies, including NVMe technology, so as to avoid repeated upgrades in the future. We deployed a Huawei solution to fit the government's demands and reliable networks. And once the devices were in place, the end-to-end latency greatly reduced, yielding a better service experience. Ashish?
Thank you. And so tell me more about this lossless algorithm and the role it plays in supercharging performance. So DC?
Yes, when we talk about the performance part, comparing to the fiber channel, our throughput can improve about 220%. And for the latency reduced by 43%. So that's huge.
Great. And then Liu Lei, let's talk about how the lossless algorithm supports reliability.
Talking about reliability, traditional Ethernet network doesn't have a proactive fault detection and notification mechanism, meaning that if the system experiences a fault, link failover is long and storage service are interrupted. The Huawei's NVMe over Fabric Plus solution is equipped with an intelligent awareness feature that enables switches to proactively notify faults in milliseconds and works with storage devices to implement sub-second level of failover. So this helps ensure zero impact on storage services in the event of a single point of failure on the network. Ashish?
Great, thank you. So now let's look at real world impact of Huawei's technology. So Jiang, I'll start with you. Tell me more about how you implemented it at Bank of China. You're on mute.
Well, currently we deployed the local NVMe solution in Bank of China. The experience is very good. Compared with the traditional FC storage network, we have seen a huge boost of performance for our local production system. And there's another feature that we value a lot, which is the data exchange between data centers. You know, for banks, we normally deploy multiple data centers in multiple locations. For example, we have 6 data centers in 5 different cities. So that means between data centers, between data centers, we have to ensure the data transmission, data exchange. And for intracity dual active deployment, Huawei NoF Plus supports 200 kilometer long distance lossless transmission using 100 GE links. So that can save a lot of cross DC links compared with FC. And also we look forward to the benefit brought by NoF solution for intercity dual active deployment. Thank you.
Thanks. So Kevin, I guess you guys have tested some of these solutions. Tell me your experience. Tell me what you've concluded.
Sure, yes, we have, and I can give you some very specific things. It's my favorite part. So recently, Tolly was commissioned to run performance tests comparing the Huawei NoF Plus solution, which as we've talked about is NVMe over Rocky, versus a fiber channel solution. So the things we've been talking about for most of this discussion, we did that test. So in this particular test, the Huawei NoF Plus solution used 25 gigabit Ethernet port, 25 gig, while the FC solution, the fiber channel solution, used 16 gig or 32 gig FC ports. So very commonly deployed FC solution speed. So the test results, very important, show that Huawei NoF Plus solution improved the storage performance with up to 93% higher IOPS or IOPS, as BC mentioned earlier. So 93% higher, unbelievable. And latency, 49% lower latency than the fiber channel solution. Again, we've talked about that today and how important low latency is. And high availability, also very important, especially to banks, right? The Huawei NoF Plus solution demonstrated less than 1 second end-to-end service failover with link and storage module failures. So we failed the links, we failed the storage modules, and we got failover in less than 1 second. And then finally, some feature tests. Our Tolly engineers verified that Huawei Cloud Engine data center switches support storage zoning, which is a very important ease of use feature in storage networks. With the zoning feature, the Huawei NoF Plus solution supports plug and play of storage and hosts. So with these ease of use features, high availability, and high performance, I'm not surprised that Huawei's NoF solution received the Best of Show award at Interop, and that Bank of China is very, very happy with it. Ashish, thank you.
Thank you. Those are impressive numbers, you know, and thanks for sharing, Zhang and Kevin. So, you know, I think in conclusion, you know, Huawei's next-gen storage network, NoF Plus, appears to be a compelling choice for the all-flash era. You know, Liu Lei, what would you say to customers who are thinking about or looking at end-to-end NVMe solutions and what they should be doing with Huawei? What would be your recommendation?
As a conclusion made by our panelists, it's obvious that our NoF Plus solution can ideally fit the needs of future all-flash data centers requirement. So I think with the innovation from Huawei, we not only just offering you the best of rate of all-flash storage, but also we will offer the relevant new generation of network, NoF Plus. So I think it will be widely adopted in the future.
Great, thank you. All right, so we are almost at the end of our panel. I'd like to conclude with a couple of slides about where IDC believes the future is headed with NVMe over fabrics. So clearly, prices for all-flash media are dropping, and they're dropping faster than what we had anticipated. And we believe that it will accelerate NVMe over fabric adoption. And as Kevin pointed out, with 400 gig Ethernet, there is clearly a preference over lossless Ethernet as the de facto approach, given some of the overhead that TCP provides. We do believe that with dropping prices of technology, it will kind of follow a similar trajectory as fiber channel in the past, where fiber channel, when it came about, it literally took over the storage industry by storm. We think that maybe that might happen again with lossless Ethernet and NVMe, end-to-end NVMe. But I think the key here is that the PCIe NVMe or PCIe move to PCIe is what really is leading to this NVMe acceleration, if you will. And all flash is definitely going to be predominant in the data center. Workloads, I think, is a big part of the story. And Jiang talked about some of the Bank of China applications. DC talked about some of the mission critical applications. Liu Lei talked about what Huawei is doing there. Kevin did some testing. So clearly there's a big push with both traditional workloads as well as emerging workloads. And we've, at IDC, we have a workload based, we look at workloads and how they're changing and how they're impacting compute and storage. And as you can see, there is a lot of good new workloads being developed, especially in the business application space, in the engineering and technical space, as well as in data management. Data management is a big workload group that has been growing faster than any other workload. And of course, then there is IT infrastructure. So we think that these workloads will ultimately drive the adoption of faster storage systems, and lossless Ethernet stands to win here. Cross-domain data management. So Jiang talked about data exchange as a capability of Huawei and NoF Plus. The three key areas are agility, management, and cost. And this cross-domain data management is really going to take off in our mind with multiple workloads in a single flash system, the use of AI-driven operations, and then, of course, the density that will allow this consolidation of workloads. And so I'd like to conclude with some essential guidance for folks on the other side listening in. The first one is, to take advantage of high performance and capacity densities to simplify the infrastructure with lower energy and floor space consumption, and to improve management efficiency. This is key because this gives you that business resiliency. Workload consolidation is something that people should consider again. All flash infrastructure, and especially high performance all flash infrastructure, can result in fewer storage platforms. It can drive higher productivity, and then it ultimately leads to lower cost of procurement and management. And then the final thing is about business resiliency with availability requirements. You can have all flash systems recovering faster. Kevin talked about links recovering in less than a second. Moving larger data sets when and where needed. The whole idea of moving data center to data center traffic on 100 gig links is a huge thing with Huawei's solution. And then ultimately, what we want to do is exhibit better reliability, and that reliability is because of the media itself. The resistance and the durability of the media itself. So we think that all flash data centers are almost here. I think they will certainly come around in the next few years, and they'll be driven by more capable storage systems like the Huawei NoF Plus. And so with that, I'd like to thank all my panelists for joining today. Fantastic insights from Kevin, from you on the testing side, Jiang on what Bank of China is doing, and then Liuli and DC on what Huawei is doing. So definitely a lot of good insights here. Thank you so much for offering these insights, and to all of you listening in, thank you for listening and for your time. Thanks.